Um, Welcome to my Python stream. Uh, so, um, we I have a little bit of a session with Python, and Python is of Analytic April. We are focusing on analytics, and I thought Python, the core of the analytic part of Python is three libraries: NumPy, Matplot, and SciPy. And I think my plan is to uh, Matplot will be the main one, but and NumPy as well. But SciPy try to get all of these three to uh, play around with them, so you as a programmer can see a little bit what are these possible. And I thought a fun little way to do it is to make a graphing program. Uh, so here's my editor. It's set up for Python. Uh, I have some extensions, so it should work really well. But what you have to do to make this whole thing work is to have installed Matplot, NumPy, and SciPy. And uh, yeah, those uh, you install them through pip. So if you want to install um, NumPy, you do pip install NumPy. Now it will tell me I already have it installed. So yeah, so that's how you install NumPy, and you do the same thing for all of them. But if you don't know what a graphing calculator is, I think I should show you at least an example what a graphing calculator is. So uh, I have, how I usually do my graphs is through a graphing calculator, an actual calculator. So I've taken a screenshot from my calculator, and you see this. We see this graph, and I will explain a little bit deeper for it. But if you don't own a calculator, and I know a lot of people don't, there is a website called Yogebra, and it's a really amazing website where you can do graphing. So let me change my screen to my web browser. There we go. Yogebra. It's a free website. You don't have to log in, but it allows us to write functions. We can say y is equal to x, and we get a line. And why would we want to graph functions? Because a function, it is a little bit of, in Python, you have a function and you do something with it. That's exactly the same in math. You have an input, more or less, and you do something and you get an output. Okay. So what, so for example, if we have the input y is equal to x, if we input 4, we expect to get 4. But if we say 2x, so we shall multiply the x we expect, if we input 2, we shall output 4. That's the simple background behind, a graph. But let's get coding. So what we have to start off with is we have to start off with importing matplot. So what we do is we do import and then we do matplot library dot pyplot. And we want to, this is a very long name, so what we want to do is just import it as plot. And then we need numpy as well, so we import numpy as np. All right. So firstly, to make this graph, because what is actually happening is we take very small, we take, to get these like nice looking graph, we have to take uh, take out values at a lot of different positions. So to do that, we can use we can do x. I name this the x value variable, so that will be all on the y-axis on a graph. And we do np dot arrange, and then we do dot o. So this says where we should start, and this tells you where it should end, and this tells you the intervals between how many value points we should get. So I don't know why this is not showing up. Let's just try to print text value. And we run this and it works. So what we end up with is a very big array with values for each point. So we get 0, we get 0.02. So it start at this value and add this until the value we have is bigger than this value or equal. So what we end up with is an array with a bunch of different numbers. And these numbers we can use as x values. And later on, we need to find a way to create y values. And so these are I showed the example with the graph and the values we plot in. So how to do that? We have to have a function. And if you're a mathematician or knows math, this is pretty easy because you know how to define a function, and that's a function. You don't really have to play a lot with it. But in a programming language, it's a little bit different. But just because of how powerful Python is, it isn't that hard. So we can do the definition of the function, which takes an argument x. And we need to also have an operation given. So what we do is we can use a very interesting operation, and that's eval. And that will, so what is very interesting with eval is that it evaluates a string, which is really, really cool. So we can take a mathematical formulation and it will be able to put in variables into that equation. And this likely exists in other languages as well, but even if we change this to my web browser, evil, so if we see here, it can actually, x times 2, and we have defined x as 100. It can actually, evil will be able to put this variable inside of here and make this 100 times 2. And this saves us a lot of, we could write a manual evaluation program, but that will take quite a bit of time, at least if we want to do complex evaluations. So this will do it for us. So, but what we have to do is to get an input. So what we do is we do uh, upper we do operation we do a def main actually. I want to do a def main, and here we can put this little thing. And so what we have to do is we have to get a user input because I want this to be very interactive. So we will do that. And how to get a user input through the terminal, because that's the easiest way, is to just do user input. So we can do operation equals input. And here we can write what the user will give us. So we can say enter operation, operation, and do this. And then we have to, because how I write math, I use 5. Say I want to do 5 up to, let me see, there we go, equals 20. For me, this should equal 25 because this is the same as 5 times 5, and that is the same as 25. But how Python or how typical programming languages do it is having 2 dots instead of having dot arrow. But I want the user to use this writing style. So what I have to do, because how this evil, it actually more or less input. So it will not like that kind of input. So what we have to do is use replace and replace this symbol, which I want the user to use, with the way Python wants it. And now we can do a very fun thing, and that is doing a list comprehension. So we can do results equals and then we can do result and then do for x in x values, or perhaps x values is not the best name. X points, no, x value is good. So a list comprehension. Oh wow, I'm not showing that either. Okay. Well, yeah, you have not hopefully not missed out, but is a shorter way of writing a for loop which builds up an array. So what we do is we iterate over each object in the x values array, and then we do the function, which is take x, and then we have to do operation. So what we do here is say for each x value, you should run this function, and with this function, you should place that as an element in an array, so we get a bunch of elements. So if I, and also, you see this x, it says, okay, yeah, it's case. It doesn't like this thing. No, yes, it doesn't follow state case, but in math, you actually use x, and I think here so sometimes in Python, you want everything to be readable, and you could argue that, a function, a variable name, which is x, doesn't tell you that much, but just because we're doing math here, it actually, that's, how you tell it in math, but it probably, okay, yeah, it says this is unused, but yeah, it says this isn't used as well, and oh yeah, we should return this as well. Yep. Because otherwise it will return none, and that's nothing we want. But so even if it says this is unused, it actually it's used here, so it's not really So let's get the result right here, and we can run it. I need to start the main loop. Main run. Okay. Enter. Now we can enter an operation. So a pretty simple one is x up to 2. And now we are left with a big array of used values. But okay, now we have made, now we have found values on, now we have created values for the x-axis and the y-axis. So we can combine these into coordinates, which we can place on a graph. And to graph this up, we will of course use a built-in matplot. No, it's not built-in, but the matplot library. And the matplot library is really powerful and allows us to do really advanced math plotting. And it may not be as advanced as GeoGebra, which I just showed you, but it can do a lot of stuff. So let's start off with creating a plot. So we do PLT sub plot, and then we do. Okay, so now we have created a plot, and this more or less says that we can plot things on it. So then we can do PLT dot plot, and here we can give it the function. So here we have to give it the x values and the results. So x values and the results. And then we can yeah, we use good at this. And oh, silly me. I have no idea why main disappeared, but it did. Operation x up to 2. And now we have this really basic looking graph. So it's just that simple to make a graph in Python. It's you have to create the dots. So you have to create the x values and you have to create the y values, and this will paint it up to you. But this lets us a little bit play around with the values we have right here. So this is a really core part of our program. It's creating the x values. And I talked about this as being the intervals. And, you can see how beautiful this is at the moment. If I change this to 2, because it was 0.02, we will see a big difference. So let me close this down. Let's run the program again and enter operation x up to 2. We will see it's actually not smooth anymore, and we can zoom in. It's actually have sharp edges. So what have occurred is that what this matplot library actually does is not drawing like smooth lines, it's drawing a straight line between each of the dots. So here is a straight line, here's a straight line, here's a straight line. So if we go back to this one, to the more detailed version. Oh, well, you're not seeing the graph. Silly me. Okay, now we can see. You see it's not smooth when we have this kind of graph, but if we do it Let me close it down again. We do x up to 2. You see, it's very smooth. And as I said, it's still drawing straight lines. So if we zoom in, this, yeah, I think we have zoomed in too far actually. Okay, I think we're zoomed in too far. Okay, this may be actually very hard to see thinking about it. But it's smooth. And so what we have done is we have so many little dots on this line. So even if the lines are straight, just because how many it is, it looks so smooth. But now we have this graph. And you may say, okay, you have now made a graph, and what are you supposed to do with it now? And that's a great question. So let's play around with it. So one thing, I can't show you my calculator because the program I had could only take screenshots. But that had it actually draw the line, which is really cool. And you can do the same with Matplots. I will show you how you can animate the creation of this graph and also make so it actually, it should start like this looks weird. So so we have to remove these lines. So what do we have to do to make this animated? So it may look a little bit complex, but what we're actually doing is just we say to run a function, and then for every run of the function we show more parts of the array. I will show you a little bit more details on it. But what we'll do is using figure. This is figure, and this is the axis and subplots. So what we will do is the figure is just the whole figure, and axis is the graph. So what we will do is line equals axis dot plot. And to not graph out the whole thing, just the starting point of this graph, we have to do x values 0, and then result 0. And then we can put a label on this one, or no, we can do that later. But then we can do ax dot set. So here we can set the limits. So what you will preferably do, the x ones, you will actually put them as the same as these actually. So it should be equal marker. So 0.0 and 10.0. So that's the x marks. And the y marks you could put in this manual, but what I recommend actually, because we're anyway drawing it, is just putting it as the result, the minimum here. So the minimum result. So this, and here we take the maximum result. So this will ensure you that but you will always see the top and bottom of the x-axis, or y-axis, and it will make sure that it because what you can do is say your graph actually goes downwards, with this numbers you can actually reverse that so it actually looks like it goes upwards. So this will make it looks always correct. So as long as you're working with a an interval like we're doing now, because that's the simplest or the easiest to start with, this makes more sense. So let me then we do ax dot legend. Oh, forget that. All right. Now we have to do, as I talked before, we have to have a drawing. We have to show it a little piece a little piece at a time. So what we do is we make a new function called that up, up, update, and we call this we it takes a variable frame. So what we do is we take line dot set x x x data. We take x values and we make it to frame. So what we do here is that I told you about we have uh, the, the the coordinates. So I update the x data, and then I take the x values until this should be on the other side. Sorry, this should be here. Where are you? Oh, these are not. What we will do is actually define a method instead of a method. That's how we will do it. Right. This is also a way to do it. We'll use this function later. So now I start thinking if it's better to use object-oriented program. We can rewrite it later if you like that. I wanted to keep it functional, but this also works. So what we do is we have the coordinates, so we take the x data and we update it with the array x values until we hit the frame. So what we actually do here is for every frame, because the frame goes up by 1 each time, we get 1 more data point. So for the first one, we have this one, and we tell it to stop here, and then we go, it renders this one, and it pauses, and then it takes as well this one, and then it just adds more and more and more and more and more of these values until the whole array is shown. And we have to do the exact same thing for but set y data. But instead you so this is that simple actually. And then of course we have to return line. So now we are supposed to do the animation. We have then to be able to do the animation, we have to import another thing. So import and then map plot library dot animation. So that we imported that animation. So what we do is we take animation dot func animation. So we have this function I've defined. So we use that as animation, and then the figure equals the figure. That's very convenient. And then the function equals update. So, and the interval equals 10 because that's the x value. And then the last thing is repeat. We don't want it to repeat, so we take repeat equals false. And then, as you always have to do, is do plat show. And this now looks good. So we run it into operation x up to. Okay, wait, I've done something wrong. Hmm. Oh yeah. Uh, what do you think? Oh yes. Let's see. Right here, this should have 0. That's my bad. That's what I did wrong. And now we see it graph. Okay, so a little mistake like that, forgetting you need to have a 0 index of x will make it upward. So you will see it gives graph just like this. But what we also did right now, by setting the x limit and the y limit, you get it to line up perfectly, which is so nice. I love it. And as I said, oh well, this is really lagging, really. But as I said, the white will be perfectly lined up just because we used min and max, and I can show you that. We can give it another, and yeah, I should also show, we can give more functions. We can take 5. We can do like 2.5 times x minus x up to 0.5. Okay, this was a surprisingly straight line. Oh wait, I think I wrote it incorrect actually. Let's just update that really quick. Oh, okay, 0.5 times x minus. Oh no, prep. 2.5 times x minus x up to take 3. Okay, so you see, it will always show, the correct values because start at 0, it doesn't go up, it never goes up, it always goes down. So see, it does an amazing job of just making it correct because we are going in negative values. I mean, we could reverse this, so it actually goes up, but that could make it a little bit confusing. So this is really, I think I really love this way of doing min max here, and I think it's that's my sort of tip if you will want a tip on how to do good graphing. But as you saw with the example here, it's you know it doesn't have any line from Origo. And most graphing software actually does, because that's so helpful to like see where 0 is. And I will not dig into the math parts behind why the 0 line is very good to be able to see. But if you know more advanced math, and if you're interested, there are likely math courses online. There's a reason why the 0 line is a really interesting line in a lot of different perspectives. So now the question is, how do we graph the 0 line? And as with everything else here, we have done a graphing calculator with, and yeah, we've used. Oh wow, now we have a lot of unnecessary lines here. So we have made a uh, graphing graphing software, I should say, not graphing calculator, with like 25 lines, and drawing two lines, because that's what we will do. We will use drawing two straight lines going through Origo. Origo is the zero. It's the where x is 0 and y is 0. So what we do, it's before we show it, we do plot dot ax h line 0, and then we do color equals black. And then we need to do the same thing for the y-axis. So this is the h takes, height, and d is the vertical line. We do 0, 0, and then we do color equal black. And voila. So we can do 5x minus okay, no. Okay, that was silly of me. I'm so used to writing. That's something which you could add. So you could write x, and because Python can't see that, oh wow, you want to multiply these, and therefore it cannot really evaluate it. So you have to write the multiply sign. Oh yeah, okay. I forgot to save animation. We need to do this to save animation. Sorry. And we do 5 times x minus x up to 1.5. Okay, now we have a graph. And yeah, also the intervals here is what controls, how fast this draws. So if you wanted to draw a little bit faster, we can do that. But what we have right now, oh, I really love this. We have a Rigo line, so we can actually see, okay, it's starting from a Rigo going up here. So this is a very nicely drawn line. But say you now want to do a little bit more advanced stuff. Now we have gone through how to, create your own, uh, graphing software in a sense, and let user pick in an input, and we can evaluate that input. But I want to take this to the next level. That I think the next level is integrals. And some of you may now say, okay, what is an integral? What is an integral? So we will do this simple. You can do like a lot more advanced stuff and a lot more stuff with it. So let's bring up this again. Because I will show you what I mean with advanced stuff, but if you 5 times. So an integral, that's the area between two graphs, you can say. So why I say people do this more simply is because, you could do the integral between two lines, uh, which is uh, it's a common thing to do, but that requires a little bit more. So we will do it a little bit easier, and that's by drawing the integral from the line to the to zero, or to the x line from the x line. And you may say, okay, what is the point of having an integral? Like why does integrals matter? So what an integral creates, because we take the area beneath a line, it creates an area, and you may say, why what does the area actually what does the area actually why do we need to know an area beneath the line? And you could use a lot of stuff with such an area. You can with such an area you can draw 3D objects, but that's another lesson, and I will not teach you how to do that. Instead, I will teach you what a little bit easier what you can use it as. And pretty commonly, say we have a graph. So let's put in labels. We now have labels on the graph. So say we have on this graph we have. Oh, let me remove this. So here we will have a label. So we will have an X label. X no X label. Say time in seconds, because that's what we will do. And then Y label will say the speed. So speed, that will be meter per second. Meter per second. So let's drop the line again. And don't know why that error is enough, but wait. Okay. So what does this area represent then? And so we can think this as a little bit simpler. So let's zoom in on this portion of it. So we are using meters and meter per second. I'm sorry if you're using another system. But so what can we tell? So we can say if I'm traveling at okay, now this becomes very no we I want a straight line actually. That's what I want. Draw a new line, Python, and then we do 5. So now we get a straight line. Okay, great. Because otherwise that will mean okay. Oh wow. This became a little bit non-centric. So yeah. I want this to out a little bit. That's what I want to do. So okay. I am not used to these consoles, but anyway, I think it doesn't really matter if we can zoom in or not. So what we can tell is that you know if I travel 5 meters per second for a second, you know, we know I've traveled 5 meters. Okay. And we can do this by graph, if we have the y-axis being 1 and y-axis being 5 and the x-axis being 1, we multiply them, we get 5. So in this situation, if a graph shows something, it doesn't always, mean something. But working with meter per second and second, that's a very, I think, easy to understand situation. And then it shows you under the graph the length. And okay, why? But if I can just do it by myself, calculate, how, I can use why should I, do this by myself or why should I have a calculator when I can just do like, draw by myself, I can or I can see how long this is and I can see how long this is. And that's a great great point. But say you have, a graph like, a graph like this, a graph x up to 2. It's a pretty simple graph. How should, like, say that you want to determine how long the person has traveled for 10 seconds, even if it's, there are graphs which is just like, go like this, and those can be really tough. This is anyway just like, it doesn't fluctuate, it's just going like this. How will we determine the length of how long the person has traveled? So here is where the integrals come in. We calculate the area under the graph, and normal integral equation is, you take you do the same thing as we did with, graphing the line. Is you take so small pieces and you puzzle them together and get the integral value. And you can do this, by paper and, calculating by yourself. And in that case, you will get the primitive function, I think it's called. I don't know if it's called that in English, but that's how I call it. And with that, you can calculate it. And I will not be showing how to do that because this is not a math lesson. This is a Python lesson. So what we will be doing is doing some built-in stuff instead of doing it manually, because we are programmers, we're lazy. Why should we sit with papers when we can let our computers do it for us? So what we first have to do is graph out the area, and just graphing out an area isn't that complicated, but graphing out an area doesn't tell us that much anyway. But let's have an integral variable, and we say input. Do you want an interval? We do yes / no, and we do. Okay, I mean it's such a but okay. Anyway, and then we do and then we do dot. Strict. So now we have, a question, and you perhaps will want to validate, but I will not do that. So what we can do is here we do if no, we do a little different. So no, we do if interval equals, yeah, we will just do it that simple. No, frick, you should such why did I expect that? So and this jump strict function, I should tell you, this removes white lines, so it makes it a little bit less sensitive for like if someone will be mistake add a space or something. And this isn't a lot more complicated than just doing ax dot fill between. Then we do the x values because we are still. I still want to draw this. I don't want to just place it out. Then we do the solve. We do frame, and because how Matplot works, it will draw this fill between different colors all the time. So we don't want that. You will see how annoying that is as we set it as color. So we can now fill between, and you could make it start at a specific value right here. So here is where you can sit and try to grab other. You could, yeah, we could actually pretty easily draw it from a different line, but here is where you can add, it will start at 4, but we make it start at 0 in any case. So now we just draw out these points again, and we say that you should draw a straight line down to 0. And, again, it's not more complicated than this. So we x up to 2. Do you want an integral? Okay, wait, I want to do on a space here as well. It looks a little. Let's see on this. Enter operation x up to 2. I want, and then do you want integral? Yes, I want. Now we see it actually draws the area between, and we will be doing a little bit special stuff with this area later on, actually. But this is how we will start. I hear my fans of my computer working. It doesn't like me doing this kind of calculations because now it's drawing, a bunch of lines and it makes it slow. But as we can see, it draws a correct integral. But you may say, okay, you have now drawn an integral. What are we supposed to do with it? And that's that's a great point. But what are we supposed to do with just an integral? Or drawn integral, I should say. It doesn't tell us anything, and you're completely right if you come to a conclusion, and if you didn't come to that conclusion, it's also fine. Since what we have to do is to actually calculate it, we have to use a mathematical method to do it for us. And here is where SciPy comes into this. I talked about that we will use NumPy, SciPy, and Matplot. Matplot is what we use most and is how we visualize things. But SciPy, I am not, it can do a lot of stuff. But what it can do is integration. They call it integration, but calculating an area. So let me bring that up to the screen so we can see the documentation behind this. So web browser. So here we have my awesome web browser. So integration, scipy.integrate. So if you have seen uh, integration in math before, they look like this. You have, this, little, I don't know what it's called, but you have this line and you say the bottom is where you start and the top, the top number is where you end. And then you have a function here, and then dx here says, I'm pretty sure it says the derivation. I don't know if that's the correct word. I only know it in my language, but yeah, you sell it to fill in. So what are we? So here is how you can compile it with using quad. Here's how you can use it with. This is gen quad. We have a lot of examples. We will not be doing this kind of stuff, even if so we will keep it simple, as I already said, and yeah. So let me think. Yeah, this is exactly what we want. We just want a simple integrate. So what we will do is just copy paste this line and import integrate into our editor. And this you saw we had a lot of examples, but we keep it simple. The point is not to the point is not to make something incredibly complex. It's to it is to keep it simple. So I'm pretty sure I've not used this a lot for a little while, so maybe I do something. Okay, I hope I have installed SciPy. Oh no, it's just saying I don't use it. Okay, yeah, that's fine. It's like, oh, didn't forget to install it, and it's like, okay, so before we show it, we want to print if interval equals I. We do print, and then we do integrate dot. Wait, oh yeah, I'm not showing my code editor. Here we go. So I added if integral equals y, we do print integrate things on. Yeah, I don't know why this function is called something, but it is. And with this one, we have to do the if this operation together with okay, yep, now I see. We have to do this. No, not capital. Okay. So the y-axis equals this. Thing, so let's just try to put x values here. Otherwise, we will do another list comparison that works out as well. But I want to try this. This may not work. I need to close down no results. Okay, great. Okay. Enter operation x after 2. 2. You want an interval, yes. Wow. Wait. Please. Okay. My camera is false. Okay, great. Now we are back. We got a result, but my gut tells me that is incorrect. So let me. I have my calculator in my hand. So let me actually, because this can actually do graphing. So what? Let me make the calculations here. So an intersection. Oh no. Great. No, this was not what I wanted. Yes, here we go. So the lower limit is 0 and the upper limit is 10. Okay. And here we actually come to this one. We were actually correct. This one we have, or sort of correct. And here is where using the range is a little bit flawed. And we can see my maths are a little bit flawed. So we have my calculator. You will, wait, let me see if you can actually, no, you will not be able to see that. But it has a very correct mathematical module, and we don't use that, and I will show you why. This says, it says 333, comma 33333. So yeah, and here it says 331. So it is a difference. Why do we have that difference? And I showed you before with the numbers dot in range why we actually gets a little bit different in result when we do the integration. So to understand this, we have to do print, and then we have to get the last value. So we do x values, and to get the last value, we get -1. I don't know why I don't know how to manage. So we run this enter operation x up to 2. Do you want to integral? Let me see. As you will see here, the last value is 9.98. That's not super accurate. So that's the flaw with a range. we are not actually getting the last value because uh, it doesn't really get the last value, and that is a problem for us. And that, in a sense, I think it could have to do a little bit with the float operation. In any case, the easiest thing uh, to do this is yeah. Now I get again very unsure. If we do x values dot end, and we will say, yeah, we're expecting because we have an NP, a numpy array, which is actually not a Python array. I expected this behavior actually, but it was worth a try. Uh, okay, yeah, I found out how to do it. So np dot append x values, and then we do have another array with 10. So, and this also equals x values. A little bit, it looks a little bit silly, but that's how you do it. X up to 2, yeah. And let's see, now when we got 10, because again, actually, this is nothing I actually showed you, but when calculating the integral, what actually matters is the start and the end and the function you have. The numbers in between actually doesn't matter. And if this was like a math channel, I would have shown why that behavior happens. But since it's not, I will not. So we now use, when we add this value, we will get correct exact value when we do integrals. Really, really nice. Uh, Let me actually see, wait, where do we have our, here we do, fill between. So I'm thinking we can do a little bit of a fun thing. We sometimes because now we have drawn the, you know, oh yeah, you didn't see it. Let me make you be able to see the graph. So let's run this again, and we do x up to 2. I want the integral, yeah. So say somebody has traveled with, their bike, and you want to know how far they got from second 0 to the 10, like how from start to the end. And we have now seen from 0 seconds to 10 seconds they have traveled 333 meters. Okay, this is really slow, but we now know how far they have traveled. And okay, but say we now want to know how far did the user travel from 4 seconds to 8 seconds. How do we do that? And that's a great, I think that's a pretty good way to be able to expand our graphing calculator a little bit more. So we can do if integral equals because what I think we want to do is create another array, and as I just said, it doesn't really matter. Or I take back what I said, but it doesn't matter the values in between because those. It depends on the graph, but we are working with such simple graphs that it doesn't matter. That's what I wanted to say. So what we will do is we will, okay, if someone wants to have an integral, we do start, we have start input, so we do input where where do you want to start your have the starting point of where uh, we take lower limit. Where should the lower limit be? And we take stop equals input dot upper limit. Okay, now we have a start and a stop. Now we actually put this in here. We take and we take x value. We take the integral x values and we treat it with this exact same behavior. But what we do different is that we take the start value right here and we need to of course convert it. Oh no, a float. We want to convert a float. Yes, it's close. I promise. And we need to convert this as well to a float. And now we put this in here and this in here. I will not let the user redefine the intervals. I'm sorry, but they don't have to do that. And to make sure it's complete, we add a stop. Okay. So now we do resolve integral and we put the whole thing here. I know, I think actually we do here is well, we will come back to that. So we have the integral system here. And that is this. Okay. So now we have an integral result. And now we replace these value actually with oh. And here we have to be a little bit more tricky. Because now you may say, okay, we should just take the x values and we should get it, but that will make it, oh yeah, I can, no, perhaps not, but this will make it very, draw it very incorrectly, the graph. So what we will do is we find let me think. Yeah, I will just show you why a little bit, like what will happen, and this is not the result we want. So we have to do a little bit modification, a little bit calculation, and this is why this isn't as simple as just drawing it the exact same way. And right here we just replace this with integral x values, and operation will still be the same, and integral. So let me run this, and I will explain to you why this will look really weird, and you will see why it's really weird. Do you want to integral? Yes. What do you want to be the lower limit? 4. Upper limit? 4. Okay, now I get warning. If given length of x. Okay, so yes, this is it. Wait, okay, it's complaining about it says weights are not equal in length. Oh, and it's correct. Okay, let's say it's been updated. Sorry, my bad. So we take x up to 2, yes, and I want the lower limit to be 4, and so now you will see it calculates the right number here, 1 and 20. Why do we get 2 outputs? Oh, I told it to print the last value. But you'll see this looks a little bit funny because it first draws, you see, it draws the integral 100% correct. It draws the 2 to 4. But, okay, wait. Let me restart this so I can actually show it while we're drawing. X up to 2, yes, 2, and 4. You'll see it actually starts drawing the line and at the same time draw this. So what we need to do is we need to control that, these are drawing at the same time. Or, no, not at the same time, I mean, so no one draws before the other line, if that makes sense. So what we have to do is we have to make sure it doesn't draw more than it shows. And how do we make sure that? So we know that a result will not have more than one x value, and we will use that. And you may see how will we use that. How will we use that? Do we say that if yes, uh, let me think for a second. How do you do this? I want to try this, but I likely not work, and it's keeping these at a different length. This will anyway be interesting to see how it reacts. This change lower limit 2, upper limit 4. Yes, didn't work. short as I thought. Uh, so as I said, we need to make sure that these doesn't convolute, start drawing before the other one. So we have to make sure that the x values doesn't come before the other x values. So, and because I've actually drawn this out, so when integral x values and x values bigger than integral values 0, bigger or equal, I should say. And we should say, wait, oh, and oh, now this should work with a big temptation to that it should. Okay, it works, but it doesn't start drawing from there. It just draws the whole line. Yeah, it's because it's part. So now we have made it so it actually starts drawing up the correct place. And we killed. We need to keep in store where this frame is bigger or equal to this frame. We have to store that. Let me think for a second. Yeah, it's a little bit thinking part right now, but we have to make sure that the values are correct. So these frame values, they don't just appear. So what we sort of have to do is, we have made sure now that, they start at the correct situation, but how do we, make sure that this is it's starting in the right position? So what we have to store is actually, when does this happen? What is the frame when this happens? So the easiest thing is to just make sure this only runs once. So we can do this a little bit sneaky. So I will define a variable. This is used, perhaps not ideal or Pythonic, but I will use to make this a little bit quicker and write this very quick. Where do I do it? Right here. So we say run once, I call it, and we name this false. So if run and sorry, and all of these are correct, then we do else. So what will we want to put in here is, you may wonder, that's a great question. So what do you want to do is count equal frame. So what we do then is we count thing in a scout. Hopefully this will work. I know this variable name is not I think it will actually be an issue, but let me see. Moment, moment of truth and broke. Yes. And of silly me on one equals false, of course. Through x up to 2, yes, 2 and 4. Here is where you will want to have it object-oriented. And I am an object-oriented programmer. I do a lot of object-oriented. This is why this happens. And you know, it can't see this variable we have right here. And that's a problem for us. Because what we have in here is I think the easiest thing for us is to actually do this a little bit different. To actually calculate the point, I think. Is, oh no, I want to define. Is to calculate the point where this actually happens. So it's pretty easy to do such a thing. So we can do while this is x dot values and we set frame with 0. With the count actually. Then we do count plus 1 and voila. Okay, now it still draws the whole thing at just one moment. This should be a value actually. So let's start debugging a little bit. X up to 2. Yes, 2 and 4. Okay, this is a 0. Still a neutral and not here. Now it should work. Okay. Yes, 2 and 4. And voila. That took a little bit of a while. But now it draws it perfectly as we wanted. Draws it very slowly, but I think we should not care about that. It draws it, and this was, you know, a quick tutorial how you can use the matplot library in Python together with SciPy and NumPy. I will upload this code on GitHub. So if you're on the Exercism uh, Discord, which you can see on the website. I will upload, I think, the GitHub there if you want to see this code, even if it's not a ton. But I hope you learned something about hopefully a little bit about math, but also what you can do with SciPy, NumPy, and Matplotlib, and uh, perhaps make a little bit of an interest in uh, computer science with Python. So that was all for me. I may do a part 2 of this, continuing. I'm rewriting this as a class instead of just having functions, and perhaps doing a little bit more of the analytic part, or I may just do some exercises. That's also fun. But I wanted to do some special analytic content for this moment. So I hope everyone has a great continuing Sunday, and or if you watch this behind, I hope you have a great day, and I hope we see each other on Discord or whatever media you use.